So, yesterday we talked about intersections, just like the word inclusive, start with the letter I, right? Everybody say intersection. Okay, everybody say intersection. Inclusive. And. Union. Uninclusive. Or. Union and uninclusive both start with a U. U-N-I. Union, uninclusive, right? So, with an intersection, I have a range of possible solutions that start at one number and end at another. With unions, we're still going to see a range of possible solutions, but it's going to look a little bit different. Okay? Let's see how different it can look. For example, let's say I have the inequality y minus 1 is greater than or equal to 7, or y plus 3 is less than negative 1. Just like some of our intersections we saw yesterday, there's nothing in common between these two besides the letter y, right? When I have an intersection like this guy on number 8, that middle expression is part of my left inequality and it's a part of my right. But sometimes if they're already split, they don't have any expression in common, just like here. So we're going to solve these two completely separate. All of our processes so far are the same, but we'll see how the graph is a little bit different, and the set notation. What's the first thing I want to do here on this left guy? Well, what's the only thing I need to do? Plus 1. Those ones go away, and I'm left with y is greater than or equal to 8. Everybody with me on that?
Yeah.
Plus 1, I get 8. What do I need to do on this other inequality? Draw the line and subtract 3. What is negative 1 minus 3? Negative 4. So y is less than negative 4. Okay. If I were to do my number line now, what number is going to be on the left of my number line, the 8 or the negative 4? The negative 4. It's much smaller. My positive 8 is going to be over here on the right with 0, a lot closer to negative 4 than 8. Right? And I'm going to add one extra term on either side of my end marks, or my little end points. Negative 4, I'm going to add a negative 5 to the left. Positive 8, I'm going to add a positive 9 to the right. Okay? What type of dot am I going to make at positive 8? Closed. So can 8 be a solution to this? Yes. What type of dot am I going to make at negative 4? Open. Can negative 4 be a solution to this? No. What direction is my arrow going to go on this 8? To the right. All y values greater than 8, like 9. So my arrow is going to be going off to the right. What direction is my arrow going to go for negative 4? To the left. All y values less than negative 4, such as negative 5, negative 6, and so on. So I said yesterday, this is the opposite of an intersection. It literally is. Intersections connect the two dots together. Unions go their separate ways. Okay? Now, the weird thing about this, right? Well, let me just ask you this. Could negative 5 be a solution to this compound inequality?
Yes.
Negative 5?
Yeah.
Yes. Could positive 10 be a solution to this compound inequality? Yes. Could 2? No. Could 0? No. Could 8?
Yes.
Yes. Could negative 4?
No.
No. Right? So anything less than negative 4 or anything greater than positive 8 could be my solution. Okay? If we're going to write this in set notation, it's going to be all real values of y such that y is greater than or equal to 8 or y is less than negative 4. This is a good one. I forgot about this one. Is that making sense?
Yeah.
Yeah, it's basically the same thing. Basically the same thing, just slightly different. Okay? Let's take one of these solutions, like 10. We said 10 could be a solution, right?
Yeah.
Let's plug 10 in here. What is 10 minus 1? 9. Is 9 greater than or equal to 7? Yes. Let's plug 10 in over here. What is 10 plus 3? 13. Is 13 less than negative 1? No. So for unions, only one of these has to work. That's why we use the word or. If I say you or your brother can come, then one of you can, but not both, right? So if I pick a solution like 10, it's going to work for one, but it's not going to work for the other. What if I pick something like 0? What's 0 minus 1? Negative 1. Is negative 1 greater than or equal to 7? No. What's 0 plus 3? 3. Is 3 less than negative 1? No. So if I have something like 0 that does not line up with my arrows, it's not going to work on either. But for these little arrows, any solution I pick is only going to work for one of these two guys right here. That's why we use the word or. If you look back over here, if I pick something like 0, right? What is 0 minus 2? Negative 2. Is that greater than negative 8? Yeah. If I plug in 0 here, 0 minus 2 is again negative 2. Is that less than 1? Yeah. So with intersections, any of these solutions along this line work for both. That's why it's and. Unions, whatever my solution might be, only works for one. That's why we use or. That might have been a long-winded explanation, but hopefully that makes a little bit of sense. Let's try this one. 10m minus 7 is less than 17m, or negative 6m is greater than 36. Yeah, give it a try on your own. Should be able to get through it. Oh, the order doesn't matter. Yeah. Yes.
Oh, let's check.
M is greater than -1 or M is less than -6. Nice. Looks good to me. All right, over here, first one, I'm going to subtract 10m over to the right. I get -7 is less than 7m. Divide both sides by 7. And I get -1 is less than m, or m is greater than -1. Does that look right?
Yeah.
Okay. Over here, I'm going to divide both sides by -6. And I get m is what? Greater than?
Less than 6.
Less than.
-6.
-6. Why less than?
Because
Oscar? Divided by a negative, got to flip the symbol. Give me a thumbs up if you remember to do that. Good. Most of us, hopefully all of us. So less than -6, greater than -1. If I set up my little number line, obviously -6 is going to be further to the left than -1. Right? Both open dots. Greater than -1 is to the right. Less than -6 is to the left. Is that a union?
Yeah.
Yes, it is. My answer, all real numbers m, such that m is greater than -1 or m is less than -6.
Does it matter the order?
It's a great question. I think it was Oscar you asked that same thing, right? When it's a union, the order doesn't matter. You could put this one first or you could put that one first. I don't really care. Okay?
But if it was in intersect, then you would pick the smaller number?
Yes, because with intersections, you're writing a full compound inequality where my lowest number has to be to the left because I read it from smallest to largest left to right. Here, it's a union. It could be either one. It doesn't really matter. I always do that and I
7.
keep forgetting that it's a thing. The order doesn't matter for unions, okay? Obviously, on the number line, the order matters. You should have a right number line, but yeah. Let's do a fun one. Are you ready to have some fun?
yeah, I'm having so much fun, guys.
Yay! Here we go. Last one. 5x minus 1 is less than -16, or -3x minus 1 is less than 8. Give it a go.
5x minus 1 is less than -6.
Like weird fun. You ever look at a math problem and go, that's a weird one. This is a weird one.
Okay.
Huh?
Yeah, me too. Hey.
You said what?
Oh.
You know what I'm talking about?
It's just got so simple.
Well, like, I can overcome it.
You can overcome it. Grab it. Ooh, nice. Good job. That looks great. Good job. It's weird, isn't it? Isn't it weird? Try and graph it. You should hopefully get the same number.
Oh dear.
See what that looks like maybe as a graph. Yes? No, I can see. Yeah. Yeah. Oh, it's easier than I thought. Right, Misty? Nice. Good job. You guys are such outside the box thinkers.
Thank you, bro. Why thank you, bro?
I know, guys.
You're supposed to get
Our
an extra.
break it.
Good job.
We're so good.
Good job. Every single number but. Nice. I like that.
What should I eat?
All right, most of us got it. Let's take a look. I'm going to quickly go through the arithmetic because it's pretty straightforward. (5x) is less than negative 15, or negative 3x is less than 9. Divide by 5, divide by 5, divide by negative 3. Oop, what happens when I divide by negative 3?
Oops.
What do?
You flip the symbol.
Flip the symbol.
Oh my god. They're the same answer.
So, they are not the same answer. I got x is less than negative 3, or x is greater than negative 3. So if I have a little number line here, all I've got is negative 3. What type of dot am I going to make it negative 3? Open. Now, for this first one, all values of x less than negative 3, like negative 4. For this one, it's all values greater than negative 3, like negative 2. What's the only thing that is not a solution to this compound inequality? Negative 3. All real numbers except negative 3. That's my little open dot. That's what technically still makes this a union. It's just like if we took them and we, if we took this little ray and slide it over until the circles overlap, that's still a union. There's just a very, very, very small window of inopportune integers that cannot be our solution. I don't even know what I'm saying anymore. All real numbers x such that x is less than negative 3 or x is greater than negative 3. There's a fancy way to write this, but I don't want to do it. There we go. I don't want to do it.